Number 1, how many teaspoons are equivalent to 44 tablespoons? And they're being nice and telling us that 3 teaspoons is equal to 1 tablespoon. So if it is 3 teaspoons to 1 tablespoon, then we're saying how many are in 44 tablespoons? This is the sort of thing, if you can see this proportion in your head and don't have to set it up, that's fine. You don't have to write it like this, but sometimes we have trouble visualizing exactly the ratios. Setting it up like this can be a really good way to make sure we're doing the right multiplication, we're multiplying the right things. So here I have my 2 ratios of teaspoon to tablespoon set up, and then I can just look at the numbers I have here. 3 is to 1 as x is to 44. To solve a situation where we have 2 fractions like this, we would cross multiply. 3 times 44 is 132. X times 1 is x. So there's my answer. X is equal to 132c. Number 2, the function f is defined by f of x is equal to 1 over 6x. What is the value of f of x when x equals 3? When we are told f of x equals something, what they're saying is, if I put a number and plug it in for x, tell me what I get. Do all that math and tell me what you get. So they're asking you to plug in 3 wherever there is an x in this equation. So there's only one x right there underneath. So I'm going to do as they say, and I'm going to plug in 3 for x. So 1 over 6 times 3. 6 times 3 is 18. So my answer is D, 1 over 18. Number 3. If x is equal to 40, what is the value of x plus 6? So x equals 40. And if we say what is x plus 6, we just need to change that x for 40. So 40 plus 6 is equal to 46. C is my answer. Number 4, what is 23% of 100? Now this may be something since there are 100 percents in all. So 23% of 100. So 23% out of 100% is equal to what out of 100? It's 23. That's sort of the logic way of doing it, but I'm going to show you the math way because they're not always going to be that straightforward. Other percentages may be given to you, like what is 5% of 78? And we don't know what they're going to give you on the real test. So let's just do the process. So 23% of 100, anytime you're asked the percentage of a number, you're going to take that number and multiply it by 23%, which in decimal form is 0.23. And when you multiply that out, you're going to get 23 as your final answer. So that's our process that we do. Calculators are allowed on this section of the test. So always be mindful of that, whether you can use the calculator or not. But in this case, A is our answer. Number 5, which expression is equivalent to 50x squared plus 5x squared? Anytime we're asked to add terms, we want to see if they are like terms. That is, are the variables identical? So in this case, we're going to look at the variables, and sure enough, they're exactly the same. They both use the variable x, and they both use that power squared, x squared. So because they are the same, we can treat it just as if you're adding 50 of a thing, and then there's 5 more of that thing. How many things do I have? So over here, they're trying to trip you up a little bit. This top one is what happens when you do 50 times 5. This is 50 divided by 5. This is 50 minus 5. D here is our one. It's 50 plus 5. A lot of times you'll note with the answers, they will try to do things that are a little close just to trip you up a little bit. But here, if you have 50 of a thing and you add 5 more of the thing, you will have 55 of that thing. That's the principle at play. So we have 55 x squareds. Number 6, the population density of Cedar County is 230 people per square mile. The county has a population of 85,100 people. What is the area in square miles of Cedar County? So population density, when we say a square mile, it means an area of land that is 1 mile by 1 mile, making a square. And it's saying that in this area, on average, this county has 230 people every time we have a 1 by 1 square. So if, let's say, the county was only 4 square miles, almost wrote 4 there, 2 times 2. So here we have 4 square miles, 2 times 2 being 4. Each of these square miles would have 230 people in it. So if I was looking at this one right here, how would I figure out how many people are in that box? Well, I would take the number of people in each square mile. I'm just going to write that as number of people per square mile, abbreviating a little bit. And since there are 4 square miles, I would multiply by the number of square miles. There's 4 of those. And I would get my total number of people, my total people right there. So in this case, that would be 230 per square mile times 4 square miles, which would give me 920. And there would be my total people. So let's use this same principle, but on this larger scale. This is our formula here. So we are told that there's 230 people per square mile. So that hasn't changed. 230 people per square mile. Now they don't tell us the number of square miles. That's what we're trying to figure out. What they do tell us is the total number of people, the population, 85,100. So basically, this is my unknown. I'm going to call this M for square miles, M for miles. So basically I have this equation, 230 people times the number of square miles equals 85,100. Now this is a more straightforward algebra equation now. So I just need to divide both sides by 230. And we are allowed to use our calculators on this portion, which is nice because, if you don't have to do lengthy long division, why not? Why do that? So we know that's 370. The area in square miles is 370. Number 7, negative 54 divided by W equals 6. What is the solution to the given equation? There's 2 ways to do this. You might look at it and go, negative 54 divided by what equals 6? And you might think through your times tables and you might see the answer there if you're doing that. But again, we're not always going to be presented with a problem like this where we know the times table answer. So let's just do the math and just solve it the long way so you'll be prepared for any question the PSAT throws at you. So to solve for W, we can't solve for it when it's in the bottom here. We need to get it out of the bottom of this fraction. So we're going to, because this is negative 54 divided by W, we're going to multiply by W to counteract that. So that undoes those two, leaving on the left side negative 54 and on the right 6 times W. Now I can solve for W by saying W times 6. So I'm going to divide by 6 to get rid of that. And I have W remaining on the right. And negative 54 divided by 6 is negative 9. So that is my answer. The solution to the given equation is negative 9. Number 8, for the function f, the graph of y equals f of x in the xy plane has a slope of 3 and passes through the point 0, negative 8. Which equation defines f? Now, if you'll notice, all of these are in slope-intercept form, which is y equals mx plus b, and we can also write that as f of x equals mx plus b. This is a very convenient format to write lines in. Very straightforward, easy to graph them. And the main components here, M and B. M represents the slope. We put in whatever the slope is. And B is the y-intercept. So they're telling us first, it has a slope of 3. So right off the bat, I go, whoop, I already know My slope is 3. Right. So far, so good. Now the y-intercept. The y-intercept means the point where a line crosses the y-axis. No matter where, get some different colors here, boom, whatever that line may be, those points where it crosses the y-axis, those are the y-intercepts. But what is true about each of these if I look at their coordinates? If I had to guess what that is, that looks like maybe 0, -4. This one looks like maybe 0, +1, and this one may be 0, +3. Do you see the pattern there? The x's are always 0 if we're talking about a y-intercept. So they've given us the y-intercept because you see up here, it's 0, -8. There's that 0. So -8 is my y-intercept. I don't have to do any math. I just have to be aware that this is slope-intercept form and know what these represent. Just really identify the information they're giving us. That's what this problem is about. Not necessarily about doing any calculations. So make this very clean. All right, so now we're just left, there we go, nice and clean. B being the y-intercept, as we just said, that y-intercept is -8. So I'm going to replace that with, come on, there we go, -8. So my final answer is 3x - 8, which is B. Number 9, we have a drawing and the note, figure not drawn to scale. So this means we cannot guess by looking at the figure and say, oh, it looks like it's this long. We have to just use math. I'm going to zoom in because I want to write on this picture. I love writing on the pictures. It says a triangle shown has a perimeter of 22 units. If x is equal to 9 and y is equal to 7 units, what is the value of z in units? So they're testing here that we know what the word perimeter means and how to find it. To find the perimeter of a shape, we are adding up the lengths of its sides. Basically is like if I had a triangular backyard like this and I wanted to put a fence all the way around it, how much fence do I need to buy? How long does that fence need to be? That's what perimeter is. So we're told x is 9 and y is 7. So if I was going to find the perimeter of this fence, I would add x plus y plus z to find the total perimeter, and they've told us the total perimeter is 22. So I'm going to put that in as my total perimeter. They've told us x, they've said x is 9, and they've told us y, they said y is 7. So now I just need to solve for z. I can combine these two like terms. 9 plus 7 is 16. So we have now 16 plus z equals 22. I need to subtract 16 from both sides, and I am left with z on the left, and 22 minus 16 is 6, so A is my answer. Number 10, the function h is defined by h of x equals 3x minus 7. What is the value of h of -2? When we're saying h of -2, the -2 goes in for x, that's what they're telling you to do. They're saying wherever in this equation there is an x, replace it with -2. There's only one x, so I'm going to put that in there. That's just times a -2. So 3 times a -2 is -6. And -7, just minus 7 just comes on down. So -6 minus 7 is -13. A is my answer. Number 11, another figure not drawn to scale. In the triangle shown, what is the value of tangent of x? If I have a right triangle, there's 4 identities they're likely to ask you about: sine, cosine, and tangent. So if this is A and this angle is B, and I'm going to say this side is 3, this side is 4, and this side is 5. If I am looking at, actually I'm going to erase that B, let's just look at angle A. If I want to know the sine of angle A, it is going to be the opposite side divided by the hypotenuse. So the sine would be 4/5. Cosine is the adjacent to that angle A, over the hypotenuse. So it would be, put it in green, 3/5. And last but not least, tangent is the opposite side from that angle over the adjacent side, the short touching the angle. So the opposite would be 4 and the adjacent would be 3. These are all very good things to learn for your PSAT practice. So this time they're asking us for tangent. As we said, the tangent of x is going to be that opposite side, which is 26, over the adjacent side, the leg that is touching that angle, not the hypotenuse. The hypotenuse isn't the longest side. It does not have a part in tangent. That's all you need to do is identify that they're asking for tangent, opposite over adjacent. And so that would be C, 26 over 7. Number 12, the scatter plot shows the relationship between x and y. A line of best fit is also shown. Which of the following is closest to the slope of the line of best fit shown? And I realized that I cut off option D, so I'm just going to write that in there. It is 2.27. Really doesn't look that great, but hey, you know what it's supposed to be. But let's center this and zoom in. They're asking, okay, for the slope of the line of best fit. So for this problem, the points of this scatter plot don't really matter. We're only looking at this line and saying, what is its slope? Which of these 4 options is the closest? So this really can be done with just sort of eyeballing it and guesstimating. We don't have to try to figure out what these points are on this line and try to calculate the slope. All right, I have 2 options that are negative, and I have 2 that are positive. So is this a negative or a positive slope? If you're looking from left to right, this is going up. If it were heading down as I go left to right, that would be a negative slope, but it's not. It's heading upward. This is a positive slope. So A and B are out right off the bat. Now I have 0.44, which is a number less than 1, and 2.27, a number greater than 1. So my thought is, what if I draw a line that has a slope of 1, because that's really easy to do, and see where this line compares. Is it less of a slope than that line, or is it more steep of a slope? So if I were to have a line with a slope of 1, it goes up 1 over 1, up 1 over 1, up 1 over 1. So there's my line with a slope of 1. It's not wanting to draw that exactly, but that's pretty close. So there's my slope of 1. This is not as steep as that. It is a more shallow slope. So it is less than, the slope would be less than 1. That's C. There's my answer. Again, you don't really have to do the math. You don't really have to do, values of x, values of y, change in y over change in x for this one. Because these numbers are so different, we can just apply what we know about slopes and find that right answer. Number 13, the y-intercept of the graph of 12x plus 2y equals 18 and the xy plane is 0, y. What is the value of y? The easiest way to do this is to take this the standard form of a line and change it into slope-intercept, by which we want to get the y by itself and have everything else on the other side. So first I'm going to subtract 12x from both sides. So on the left side, I am left with 2y, and on the right, I have negative 12x plus 18. Then, because it's 2 times y, I'm going to divide by 2, so I need to divide by everything there by 2. I'm undoing that 2 times y. So on the left, 2y divided by 2, that cancels out. I'm just left with y. On the right, negative 12x divided by 2 is negative 6x. 18 divided by 2 is 9. So when you have something in the form of y equals mx plus b, the m, the constant next to the x, is our slope, and the number that's all by its lonesome is our y-intercept. So here our y-intercept is 9. So that coordinate for that y-intercept would be 0, 9. What is the value of y? It is 9. Number 14, a model predicts that a certain animal weighed 241 pounds when it was born. Now I'm going to start writing as I read this. I'm trying to, with word problems, they usually throw a lot of information. So right off the bat, I start writing down what I'm told. So, okay, so it's 241 pounds when it's born. This is a big animal. And that the animal gained 3 pounds per day. Okay, 3 per day for its first year of life. This model is defined by an equation in the form of f of x equals a plus bx, where f of x is the predicted weight in pounds of the animal x days after it was born. Okay, so we're telling us that when I plug in numbers, I'm going to get the weight, and x is how many days. So a and b are constants. What is the value of a? Well, this is more of a logic problem and kind of like interpreting, understanding how equations are made, as opposed to doing any math problem solving. So let's look at this equation and see if we can see what logically a and b would be. So what it's saying is there was a number, just a plain number, and this number does not change. A. Nothing is multiplied by a. No matter how many days have passed, a stays the same. So there was a number, and then adding to it a second number, and that number is going to change because as the number of days changes, like it's say if this was b times 10 days, b times 15 days, b times 18 days, then this number, b times x, is going to get bigger, right? Okay, so what's getting bigger with this animal? It's gaining weight, and it's gaining 3 pounds every day. So how much did this animal weigh on the first day? When it was first day it's born, it weighs 241 pounds. What did it weigh the second day? Well, it had that initial 241 pounds, and then it gained 3 more pounds. How much was it the third day after that? It gained another 3 pounds. Now it's up to 6. How much did it weigh the day after that? Another 3 pounds. So now it's up to 9. Doesn't that look an awful lot like what's down here? We have this number that's staying the same. And then over here, I have 3 times 1, 3 times 2, 3 times 3. I am multiplying 3 by the number of days that have passed. So, there we go. So that A is going to be that starting weight of 241, and that B is how many pounds per day that animal is gaining 3 times however many days it's been. So 241 plus 3x, and they're saying what is the value of A? That was the starting weight is what was going in for A, so 241 is my answer. Number 15. The graph shows the height above ground in meters of a ball X seconds after the ball was launched upward from a platform. Which statement is the best interpretation of the marked point 1.0, 4.8 in this context? Now, before we look at the answers, let's just look at this graph, and so we know. Right here is saying we have it was launched off a platform, it goes up, and then it comes back down. This is our height, so this is showing it got up to about 5.5 meters. Like saying at this point, it's just below 4 meters. At this point, it's at 5 meters. At this point, it's 5.8 meters. And what are these points? It's how long it's been in the air. All right, so at half a second, it's this high. It's about that high. So at 1 second, it's that high. At 1.5 seconds, it's about 2 meters high. And it lands on the ground before even 2 seconds have passed. So that's what this graph is representing. It's how high it goes over time. What the ball is actually doing is it's going straight up and then it's coming straight down in this case. Because it's just going, you're on a platform, you're standing, you throw the ball up, and then it goes all the way off the platform onto the ground. But this is showing how long it takes for that to happen. So this point right here, this is at 1 second in, and it's right below 5 meters. So if I'm looking at that, I go, okay, it means that at 1 second, it was maybe 4.8 meters off the ground. That's my guess, just looking at it. And then, yep, sure enough, it said at 1.0, 4.8. Ha, it gave it to us. I forgot about that part. So what does that mean? Let's look at our options. 1 second after being launched, the ball's height above ground is 4.8 meters. That looks pretty accurate to me, but let's look at the other 3 just to make sure there's not something tricky and that it just sounds correct. It's always good to read through, even if the first one seems like 100% the right answer. 4.8 seconds after being launched, the ball's height above the ground is 1.0 meters. Nope. 4.8 seconds isn't even on this graph. It would be out here somewhere. So that one is out. C, the ball was launched from an initial height of 1.0 meter with initial velocity of 4.8 meters per second. There is no information about velocity in this chart that we're given here. And the initial height of 1.0 meters, no, the initial height was about 3.7 meters maybe, because this is our height over here. No, that has nothing to do. And then D, the ball was launched from initial height of 4.8 meters with an initial velocity of 1.0 meters per second. Nope, it was not launched from 4.8 meters. Again, it was launched from 3.8. This is not telling us velocity just by looking at those 2 points. We could calculate velocity, but no, we are just, what we are being told from that point is just at 1 second, it was 4.8 meters in the air. So that is confirmed. A is our answer. Number 16, based on a random sample from a population, a researcher estimated that the mean value of a certain variable for the population is 20.5 with an associated margin of error of 1. Which of the following is the most appropriate conclusion? A lot of words there. They love the big word problems. So the mean value he reaches is 20.5. It says there's a margin of error of 1. The margin of error means it could be 1 higher than this. It could be 1 lower. Like I calculated 20.5, but the actual mean could be as low as 19.5, and it could be as high as 21.5. It can be -1 or +1 in either direction. So that's what they've told us up here. And so then they're asking, which of the following is the most appropriate conclusion? So let's see which of these 4 comes closest to this fact. A, it is plausible that the actual mean value of the variable for the population is between 19.5 and 21.5. Right off the bat, letter A looks like our answer. But let's look at our other 3 just to be sure. B, it is not possible that the mean value of the variable for the population is less than 19.5 or greater than 21.5. No, that's not true at all. This guy may have done the math wrong. It said it was an estimate. He estimated it was in this range. So it could be 19.3. It could be 21.8. We don't know. This was an estimate. So saying it's not possible. No, that's not true. B is out. Goodness, why doesn't it want me to? There we go. B is out. C, every value of the variable in the population is between 19.5 and 21.5. Every value of the variable, when we say mean, we're talking about an average. We are averaging all these numbers together. So let's say if I was averaging like test scores, and let's say I had 100, and then I had an 80, and then I had an 86, and then I had a 72. And if I average those together, well, pop those in my calculator, and my average of those is 84.5. Does that mean that every number, every test score I had was in the 80s? It was really close to this 84.5? No. I have this one outlier at 100. I have another one at 72. When you're averaging, you can have these numbers that are way higher or way lower. It doesn't mean they have to be in there. So C is out. Doesn't want me to write it out. There we go. D, the mean value of the variable for the population is 20.5. No, it doesn't mean that, because the mean doesn't mean that. Because there's a margin of error, and it's an estimate. So it's not absolute that it's 20.5. It can be anywhere in this range, and the actual number may be slightly outside of it. It's just an estimate. So our first, we said A is the right answer. It is confirmed. A is our right answer. 17, 7m equals 5 times n plus p. The given equation relates the positive numbers m, n, and p. Which equation correctly gives n in terms of m and p? Anytime you see give something in terms of something else, they're wanting you to isolate it. They want you to get it all by its lonesome and everything else on the other side. So in this case, we are being asked to isolate n. We want n to be given in terms of m and p. So that means they want it to be n equals and everything else over on the other side. They don't want you to solve for n in the case of finding it's what does n equal? Is n equal to 5, to 7, to 25 million? No, they just want n by itself, everything else on the other side. So to do that, I'm going to step by step isolate n. First, I've got this 5 out here by itself. being multiplied times n plus p. So I'm going to divide everything by 5. So on the left, I have 7m divided by 5. And on the right, I have n plus p. Well, I am adding p to n. So to undo that, I need to subtract p from both sides. Zoom out a little bit, move up. So on the left-hand side, I have 7m over 5 minus p. And on the right is just n. So I've done it. I've got an n by itself. 7m over 5 minus p. B is my answer. Number 18. Rectangle has a length that is 15 times its width. I always start drawing. The instant they tell me I have a shape of some sort, I'm always going to start drawing. It has a length that is 15 times its width. So, okay, so this is my width, and this is going to be my length. The function y equals 15w times w represents this situation. I'm going to pause there for a second. Okay, so they're saying w and 15 times w. So clearly we're using w to represent the width. And since the length is 15 times longer, calling it 15w. All right, so y equals 15w times w. Boom. So length times width, and y is going to be the area in square feet. Makes sense, right? Length times width is how we find the area of a rectangle. And there's my width, and there's my length. All right. So y is greater than 0. Yep, area is greater than 0. Which of the following is the best interpretation of 15w in this context? Well, if I'm looking at it before I even look at the answers, I go, all right, well, 15w is how long the length of this rectangle is. 15w is my length. So look at our options. A, the length of the rectangle in feet. This is the third time that we've had these, which of these is best, and it's been A. I think it's the third. It's been a lot. So the length of the rectangle in feet, right off the bat, I'm like, that looks right. I think that's right. Always a good idea to read through all 4 of them, though. B, the area of the rectangle in square feet. Nope, we already know y is the area in square feet. The difference between the length and the width of the rectangle in feet. No, the difference would be 15w minus w, or 14w. Nope. And D, the width of the rectangle in feet. No, we're told the width is just w. So yes, confirmed, A is our answer. Number 19. X plus 2y equals 6 and x minus 2y equals 4. The solution to the given system of equations is x and y. What is the value of x? Well, anytime we have a system of equations, the most common ways to solve it would be substitution, elimination, and graphing. Now, when I'm looking at this, I see that these two are already set up to cancel out if I add these equations together. So elimination is going to be my best bet. So I'm going to add these two equations together. X plus x gives me 2x. 2y plus negative 2y cancels out. And 6 plus 4 is 10. So I am left with 2 times x equals 10. Now all I need to do is divide both sides by 2. And I get x equals 5. So B is my answer. Number 20. The table shows the frequency of values in a data set. What is the minimum value of the data set? All this is, they're saying minimum value. This frequency doesn't matter. They just want you to look at this list of values and say, what's the smallest number? That's literally it. So the smallest number there is 19, and that is your answer. Number 21. A number x is at most 17 less than 5 times the value of y. The value of y is 3. What is the greatest possible value of x? Let's put this together into an equation. So it says a number x is. When it says is, that usually means equals. But then it says at most. So x is at most. So it's not bigger than it. It's going to be less than it. So it is less than, or it could be equal to. So it could be that, but that's the most it could be. If it's anything, it's going to be less than that. So it's x is less than or equal to. And then we have this 17 less than. 17 less than means I'm subtracting 17. 17 less than 5 times the value of y. 5 times the value of y. There's my equation. X is at most 17 less than 5 times the value of y. If the value of y is 3, plug that in there for y, what is the greatest possible value of x? Well, 5 times 3 is 15. So I know x is less than or equal to 15 minus 17. 15 minus 17 is negative 2, so x is less than or equal to negative 2. That is the greatest possible value of x, negative 2. 22. What is the positive solution to the given equation? And just like that, they hit the gas and went into, in my opinion, a much more difficult problem than some of the previous ones. So it is factoring, but not just any factoring. We have factoring with a 5 out in front. I was surprised by that. Okay, the two main ways that I would go about doing this would either be by factoring it or by using the quadratic formula. So I am a factoring girl. I like to factor things, and it's something that makes sense to me, so that's the method I'm choosing. If you want to use the quadratic formula, that method works equally well. So if you're factoring and the first coefficient is not 1, let me make this a little bit smaller there. We have 5. What you do first is you multiply those two together. 5 times negative 24. So 5 times negative 24 is negative 120. And then you take that middle number, negative 37. Now, once you have these two numbers, you're trying to do some problem solving here. You're wanting to figure out what two numbers multiply to get 120, but add to get negative 37. Okay, so I'm going to make a list of things that multiply to 120, and I'm going to ignore the negative for a second, because just know that, like, say, example, first one, when I say 2 times 60, this could be negative 2 times positive 60 or 2 times negative 60. Now, when I write these out, I'm going to look for ones where if I'm either adding or subtracting them together, I get to negative 37. So they either want to add up to negative 37, but because it's a negative, you're like, I'm looking for a difference of 37 between the two. So what goes into 120? 2 goes into 120 60 times. 3 goes into it 40 times. And right there, right off the bat, I'm like, wait, 3 and 40 are 37 apart. I think I found it already. So what if this was a negative 40 and a positive 3? Those would add together to get negative 37, and they would multiply together to get a negative 120. So I've already found my answer. I don't have to go any further. So yeah, you don't have to write out all the possible things that go into it. You just want to be testing as you go so that you don't have to do more work than you have to in these tests where there's a time pressure. Right, so now I know 3 and negative 40 are my two, so I am going to solve this or factor it by grouping. So I'm going to write negative 40x plus 3x minus 24 equals 0. And if this is something that's very new for you, I would suggest going to the links in the description below that goes really into detail on factoring by grouping, stuff like that, because for these, I'm going over the concepts, but not as in-depth as some of those long-form topic-focused videos are. Right, so first, 5x squared minus 40x. What's my greatest common factor? 5 goes into both of those, so I can bring that out. And x goes into both of those, so I can bring that out. That leaves behind x minus 8. Over here, hopefully, if I've done it right, I can pull something out that will leave x minus 8 behind. There is that greatest common factor of 3. So if I pull out a positive 3, sure enough, it leaves x minus 8 behind. So I have fully factored this. It is 5x plus 3 times x minus 8. And then if I solve both of those separately, let's say 5x plus 3 equals 0 and x minus 8 equals 0. Well, just long experience tells me this is going to be the one with the positive answer. So I'm going to add 8 to both sides and get that x equals 8. So that is my answer. But if you want to see this one, on this one, I would subtract 3 from both sides. This just keeps going. I keep moving up. And I would get 5x equals negative 3. And then divide both sides by 5. x equals -3/5. And if you recall, they asked for the positive solution to the given equation. So this -1, we don't need it. We only need this positive one. So it is, man, it's a long, that's what I said. I think they stepped up a level of difficulty on that problem. X equals 8. So C is my answer. All right, let's zoom back in for this one. Number 23, figure not drawn to scale. In the figure shown, lines R and S, there's our two lines, R and S, are parallel. All right, parallel. And line M intersects both lines. If y is less than 65, which of the following must be true? They are testing your knowledge of how a transversal, that is a line that crosses two parallel lines, what kind of angles does it make? Anytime you have parallel lines and a transversal, there's a whole bunch of relationships that happen. And if you want more details about why this is true, I have videos on this below. But for this purpose, I'm just going to tell you the facts of what is true here. These four angles are all the same. And these four angles are all the same. And in this case, so I've got, I have these four angles that are all the same. And then those green ones are all the same. So make that really clear. And the green angles and these purple-blue angles are going to be supplementary. That is, they're going to add up to 180 degrees, which you can see it when they're right next to each other. But because they're the same across, it would mean that this and this is supplementary, or this angle and that angle are supplementary. So that's the knowledge they're testing you on. So over here, these angles, just rotated it 90 degrees, are all are all congruent. And these are all congruent. And again, those opposite colors are going to be supplementary. So y is a green angle and x is a red angle. They're going to be supplementary. So x plus y is going to equal 180 degrees. I'm going to erase this here. So y is less than 65. So let's pick a number less than 65. Let's say y is 64. What would x be? Well, let me subtract 64 from both sides. And x is going to be 116. So which of these must be true? So this, let's see this statement that if y is less than 65, I've discovered that x is 116. Which of those agrees with this? First, I have x is less than 115. Nope, already discovered it's greater than that. So boom, that's out. X is greater than 115. Yeah, that is true. Next one, x plus y is less than 180. No, we said x plus y equals 180. X plus y is greater than 180. Nope. B is the only one. We don't have to do any further work. And you see this as like these are making up a line. So if y was less than 65, this could be all the way down to be like y could be 10, y could be 5, y could be anything less than 65. So if y were equal to 65, x would be 115, but because y is less than 65, it must be greater than 115 to both add up to 180. Moving on, number 24, f of x equals a minus 19 over x plus 5. In the given function f, a is a constant. The graph of function f in the xy plane where y equals f of x is translated 3 units down and 4 units to the right to produce the graph of y equals g of x. Which equation defines the function g? The concept several times in this module, this section here. It's this concept. Let's say if I have a function y equals x squared, that is just a parabola that's has its vertex at 0, 0 and opens up. There's certain rules about functions where we can add or subtract numbers and how it's going to move that function around. So if I had y equals x squared plus 2, that plus 2 is outside with the x squared. It's going to move this, any number that's outside of it is going to move it up or down on the y-axis. It's going to move it directly. So this is plus 2, so it moves it up 2, and it would just be the same parabola, but up 2. Now, if this number was inside with this x, so let's say it was x plus 2 squared. It was inside, not sitting out here, outside. Inside, this is going to move it left or right, but it's going to move it the opposite. So this is a plus 2. It's going to move it towards the negative x, 2. So it would go 1, 2 to the left towards the negative. I'm drawing it poorly, but the parabola doesn't change shape. It just moves to the left. There's that sort of principle. If you put a negative out here, it's going to turn it upside down. Or move it to the left too, and then turn it upside down. You can combine these quite easily. So if this was x plus 2 squared plus 3, that would move it to the left 2 and then up 3. 1, 2, 3. So it'd be the same parabola, to the left 2, up 3. They're testing you on this knowledge, and it gets used again several times in this section. So it's a good thing to know, because obviously it shows up. They like it. So here we have a minus 19, where a is a constant. A is a constant just means it's a number. So a minus 19. It doesn't matter for this equation. You know, the a doesn't do anything because it's just a number. It's not another variable. It could be 5. It could be 25. It doesn't matter. The x and the plus 5 outside are the parts that are really important, because this is just the same as a number. Right. So it's going to be translated or moved 3 units down and 4 units to the right. So down, that is this number out here. That is moving up or down. So at the moment, it started, because what you're starting with is just like a 1 over x. That's the sort of base function that's being changed here. So this 1 over x, in this case, some number over x, but it's the same type of function, moved up 5. But now they want to move it down 3. So we're going to subtract 3 from that, and that will leave 2. Now it wants to move to the right 4. So wherever the x is, we want that moving to the right to be attached to that x. So I'm going to, that thing on top, a minus 19, that stays the same. But that x on the bottom, I want to move to the right 4. That is towards the positive x. So we do the opposite. It's going to be x minus 4. That's it. A minus 19 over x minus 4 plus 2, which is b. They really are just testing that knowledge that when you put in a number with that x, it's going to move it left or right. But the opposite, when you have the number sitting outside by itself, it moves it up or down directly. And that's your final answer. 25. A machine launches a softball from ground level. Okay, so we're on the ground, and it goes whee up in the air, and it comes back down. It reaches a maximum height of 51.84 meters. So it's up here, 51.84 meters at 1.8 seconds. This is going to be my seconds. Using very similar to, this is going to be my height. Down here is going to be my seconds. Okay. Very similar to a previous problem as far as our setup. And it hits the ground at 3.6 seconds. Which equation represents the height above the ground, h, in meters of the softball, t seconds after it has launched? Okay, so height is h. Again, our y, that's our h. And then seconds is going to be represented by t for time. So looking at these equations, and again, the easiest way I think to do this is to think about what I just discussed in number 24 about taking an equation and moving it left, right, up, or down based on how things change. It's going to be the easiest way out of this, I promise you. And not trying to figure out and do this math and be like, oh, what's the speed of velocity? Easy peasy this way easier. Right, so t squared. T squared is a parabola. If t squared was written, it would be like this. But it's not. It's down. So what happened first? It was made negative. It's a negative t squared. If you notice, all 4 of these are negative. All right, so right off the bat, I know it became a negative t squared. So, okay, got that. Then this negative t squared, where did its vertex move to? It went to the right 1.8 and it went up 51.84. I do not know how steep this parabola is. I don't know if it's like this, if it's like this. I don't know that. That steepness, as you would, is the number that's in front of the t, whether that's 1 or 16. that number is affecting, how steep, for lack of a better word here for this type of problem, that parabola is. I don't know that fact right off, so I'm going to ignore that. I'm just going to focus on that vertex. It starts at 0, 0, and again, it moves to the right 1.8, and it moves up 51.84. Now, we said, what moves something left or right in a function? It's when you put a number in here with that t. So I'm going to put in with that t. It goes to the right 1.8. It goes toward the positive x. So you need to do the opposite, minus 1.8. And then what happened? It goes up 51.84. So how do I adjust the function to make it move up 51.84? That's going to be a plain number outside, and it's direct. This is toward the positive y, so it is a positive 51.84. Now again, I don't know what the arc of this is. I don't know what the velocity of that softball was, so I don't know if there should be a number out here or not. But let's look at our answers and see if there's anything that's close to what we've written here. Negative t squared plus 3.6. Nope, not even close. Negative t squared plus 51.84. All right, we've got that plus 51.84, but we don't have that minus 1.8. That one's out. Now, both of these have negative 16. So I go, okay, so I'm going to assume now that that's, because the first two I know were wrong, that negative 16, that is the number out front that it should be. And what do we have? We have minus 1.8 squared minus 3.6. No, that does not match. And ding, 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 there's our answer. Negative 16 times t minus 1.8 squared plus 51.84. D is my answer. 26. In triangle ABC, the measure of angle B is 90 degrees and BD is an altitude of the triangle. Okay, so ABC, I'll try to draw this a little better. Close enough. Angle B is 90. ABC, and BD is an altitude. So an altitude is a line that comes straight down as the height, so it's forming a right angle at the bottom. BD is the altitude. The length of AB is 15, and the length of AC is 23 greater than the length of AB, which is a fancy way of saying 15 plus 23, or 38. So that is AC is 38. Right. What is the value of BC divided by BD? Wait, what? Do I need to do like Pythagorean theorem to figure this out? But then how do I figure out the altitude? The easiest way to do this, I've seen this type of problem before on another practice PSAT that was provided by them. So clearly they like this. Keep an eye out for this type of problem. There are similar triangles at play. Anytime you have overlapping triangles, and we do in this case, we have a couple of them. We have this big triangle, ABC, and then we have this triangle, BDC, and we have this triangle, BAD, the bad triangle. So I have three triangles, and two of them, ABC and BDC, have the right angle. Well, all three of them actually have a right angle in them. So there's a potential for similar triangles all over the place because we have shared angles. Because if you look at ABC, angle A is one of its angles, and BAD, angle A is one of its angles. As soon as you have two angles that are congruent, you have similar triangles. So BAD is similar to ABC. But also over here, BDC has angle C as one of its three angles, and BAC has angle C as one of its three angles. So BDC and ABC are also similar. But what do they want? They want BC to BD. BC and BD are part of this little triangle right here. So I'm going to forget about the bad triangle and I'm going to look at BDC and how it relates to ABC. So I'm going to draw BDC down here. And so, okay, so I have B, so D is at the top. I'm rotating it like this. D is at the top. And then this would be B over here, and this would be C. So I'm just kind of spinning it down. Okay, now this looks a little different than that one. Well, it should, because they're sharing angle C, and here angle C is on the right-hand side, and here angle C is on the left-hand side. So I'm going to flip it one more time. Draw it that way. So angle C is here and angle B is here. So now they look, it's easier to see the corresponding angles. So I know they both have a right angle and they both share angle C. So there's my similar triangles. Now I am going to write a similarity statement. Trust me on this, it will help. So, and you make sure that the corresponding angles line up or match up in this statement. Honestly, this is the hardest part, just making sure that you interpret this triangle and getting it to this point correctly. So triangle, bottom left corner to right angle to shared angle C is ABC. It is similar to triangle, bottom left corner to right angle to shared angle C, BDC. Once you have this similarity statement, you can very easily set up proportions just by saying what corresponds. So A is to B as B is to C, first to second is second to third, is the same as B to D to C. You can say A is to C as B is to A, is the same as B is to C as D is to B. You can set up these proportions very straightforward, very easily. So what are they telling us here? The length of AB, A is to B, is 15. And the length of AC, A is to C, is 23 greater, or 38. They're saying A to B is 15, and that. So that ratio, A to B, B to C. Well, let's look what ratio they're asking, and then we can set this up really easily. They're saying, what is B to C over B to D? B to C over B to D. Look, it's those same two. It's the first and the last. Here, the first and the last. And then the first two. So these same, even though the lengths are not the same, the proportion is still the same. So this triangle over here, the first to the last letter is 38 over the first to the second letter, 15. So over here, same proportion. First to the last would be 38. First to the second would be 15. So there's no calculating required. That's it. Our answer is D, 38 over 15. This one really is wanting you to recognize those similar triangles. Again, I've seen this type of problem before, so it's a good thing to practice and look out for on the PSAT. They like it a lot. Last one, you've made it, 27. F of x equals x plus 7 squared plus 4. It's another one. Told you there were 3 on here. Another one where they want you to know how to move a function around by adding numbers to different parts of the function. So we are starting with an x squared, which is just a little parabola, looks something like this. The vertex is at 0, 0. And we have that number out here on the outside. That is what moves it up or down. In this case, it's direct, so it says a plus 4, so it's going to move it up 1, 2, 3, 4. I'm not using the graph in the background, sorry. Probably should have, so moved up 4. And then the positive 7 inside there with the x. The numbers inside the x, once again, move it left or right, but the opposite way. So this is a plus 7. It's going to move towards the negative side of the x. And it's going to move 1, 2, 3, 4, 5, 6, 7. Again, not using the graph paper, just doing a little rough version here. It's like, okay, so I've moved up 4 and to the left 7. So that is my new parabola there. So the function f is defined by this given equation, which I've done a very rough drawing. Again, we're just sketching it out quickly so we have something to look at. For what value of x does f of x reach its minimum? Well, there's our minimum right there, our vertex. What is the coordinate? Well, x comes first, and we went negative 7x, and we went up 4. So that's negative 7, 4. And it's saying, what is the value of x? The value of x there is negative 7. That is the easiest way to do this. You can also, if you just, really like doing longer math than you have to, you can expand that. You can multiply x plus 7 times x plus 7, then add 4. Then you can use x equals negative b over 2a to find the axis of symmetry, and then find out, what that value is for the for the x, you can. And it's going to get you the right answer. It absolutely will. But I think having that knowledge of how those numbers move this across the board is a much more effective use of your time in this timed test. And that is it. You have reached the end. Woohoo! Congratulations. If this was helpful or useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.